if we come to this fission process, what I am saying is you can split the nucleus if it is ready to split. Means if it is ready to split means what I'm saying, if it is unstable. That's why which one we prefer here is the unstable nucleus, means heavy nucleus. Okay. Suppose E is bombarded, collided, bombarded with a nucleon with another element, or okay, what we say, bombarded with better write with an element or nucleon. Better I say with a nucleus or nucleon. Okay, then it will be splitted into the daughter nuclei and one more thing they found here, releases an amount of energy okay to balance the mass effect here. So releases an amount of energy. Okay, this is called as nuclear fission. Okay, in this nuclear fission, basically during that Second World War, they did the experiments, and in those experiments here, yes, okay, no problem, Ananiruddh. So here,
Good morning, sir.
during that Second World, good morning, Bhargav. During that Second World War, what they did, some experiments on this nuclear fusion. Okay, and of course, they found at Tahan and Strassman, they found the nuclear bomb, and that was released where all those things, you know. Okay, basically, first they did one experiment, means here whether the heavy nucleus when bombarded with some suitable nucleus or nucleon, whether it will be splitted or not. Okay, to check. First, they used uranium, Nana. That's why usually when we come to the explanation, we explain with the uranium nucleus only. Why? Because they did first the experiments on uranium. In that uranium also, here problem is when you take the uranium, okay, in the uranium, again we can find two types, Nana. Generally from the natural ore, means from the earth, if you take out some amount of uranium ore, what we call, in that we can find in 95 to 98% uranium 238 we get, Nana. Okay, and uranium 235. Okay, the suitable here a suitable element nucleus for the fission is uranium-235 nana. Okay, keep in mind, very less amount you can find from the natural ore. If you dig and take out the uranium from the earth, in that nearly 96% here you can find uranium-238 nana. Just 4% only uranium-235 unavailable naturally. With 4% of uranium-235, how to prepare 1 ton or 2 ton of uranium bomb, nuclear fission bomb? Okay, so this is a $1 million question initially. Okay, of course, here they found some reactors. In those reactors, they converted this uranium-238 into uranium-235. Such type of reactors are called breeder reactors. Such breeder reactor, even it is there in our Hyderabad, near ECIL Nana. NFC complex, we say, nuclear fuel complex. Okay. In the nuclear fuel comes NFC. Okay. At NFC, you can find this breeder reactor where the uranium-238 can be converted into uranium-235. Means what I'm saying fundamentally, the non-fissionable nucleus is converted into fissionable nucleus. Okay, why? Because naturally its availability is less. That's why we have to transfer the non-fissionable uranium to fissionable uranium. Okay, so such type of reactor, what we created, we means the humans created, such type of reactor is called as breeder reactor. After converting uranium-238 into uranium-235, here that uranium-235, how to split into the daughter nuclei, we are going to discuss. Later I will explain about the breeder reactor, Nana. First we go to the fundamental concepts here. Okay, now this uranium-235 reaction I am writing here. Okay, reaction is for splitting what we are using. Right, I am writing here uranium-235, of course 92 atomic number. They bombarded with one neutron, means they using nucleon here, bombarded with neutron. Neutron is also a nucleon, that's immediately captured by the nucleus. Okay, after capturing, immediately they found, of course, it is transformed into uranium-92-236 and immediately disintegrates into. While disintegrating, keep in mind, the uranium means one uranium may be splitted into many daughter nuclei, Nana. Okay, at that time, it may split into 3 daughter nuclei or 4 daughter nuclei or 2 daughter nuclei or more number of daughter nuclei. So it is split into 2 or 3 or 4 or 5 or 6, we can't predict. Okay. So here, sir, it may be split into any number of nuclei, means how to write the reaction, sir? First question arises. In that, again, we see the probability. More number of times it is splitting into how many number of nuclei we see. So depending upon the most probability, they found it splits into 2 number of nuclei. Okay, so whatever I'm writing here is not the reaction occurring all the times. Keep in mind, it is most probable reaction I'm writing here. That most probable reaction is it is split into barium and krypton. Okay, barium mass number 141. Okay, krypton mass number 92. Atomic numbers, I think all of you know, krypton 36, barium 56. If you see here, the reaction is not balanced. 56 plus 36 is 92. Atomic number, it is balanced. 92 plus 0 is 92 only. But at mass number, if you see 236, if you add these two, you will get 233. Still 3 less there. That's why additionally, to balance the reaction, here they found 3 more neutrons. Okay. So here 3 more neutrons, and if you see the mass defect between the parent, okay, and the daughter, they found some mass defect. That mass defect is converted into energy, means this is exothermic reaction. And in that nearly they found 200 MeV of energy is released, just by splitting only one uranium nucleus. This is by one uranium nucleus now. Okay, 200 MeV of energy they found. It is what I write, the most probable reaction. Probable reaction. Okay, so the uranium 235 may be splitted. Excuse me, here may be splitted. Into 2 or more daughter nuclei. What I explained here in the theory. Okay. Later, if you see, here the objective question is, particularly uranium 235 is splitted into daughter nuclei by bombarding with the neutron. Okay. This is the basic theory. From the basic theory, what are the objective points, sir, when we come to competitive exams? One, they ask, here the points, key points, what we have to remember. From the explanation. If I ask uranium 92 to 35, fission of uranium 92 to 35 after bombarding with a neutron, how many neutrons will be released in a reaction? If I ask, what do you say? Your answer?
3 neutron.
Yeah, good. So in exam, if they ask this question, you put 3. Am I right? What from Mandua?
Sir.
Are
Hello,
you telling
sir.
anything?
No, sir.
Yes, yes, yes. Then why you open your mic? Unmute. Then here, I say that is not the answer. Why? Because clearly I explained here, uranium 235 may be splitted into barium and krypton, 2 nuclei, and are also more number of nuclei. Okay. This is most probable reaction only, not the final reaction. Keep in mind. It depends upon the daughter nuclei here. Yes, correct. So in this case, you found 3. Okay. If it is split into more than 2 daughter nuclei, the number of neutrons will be different in each reaction. That's why uranium 92 to 235 is splitted. Then how many neutrons are released means you should not say most probable number of neutrons. Okay. So by seeing all the reactions, possible reactions, and we have to take, we can see find a different number of neutrons in each reaction. Nana. You have to take the average of all those. So the average number you have to say. So first point where we are doing the mistake, the number of neutrons. What happened? Oh, sorry. Number of neutrons released in the uranium fission reaction. Okay, fission reaction in uranium fission per each reaction. Okay, per reaction is 2.5. Okay, this is average number. Keep in mind. If you take the average number of neutrons released in each reaction, okay, depending upon the number of daughter nuclei, finally they found average number is 2.5. That doesn't mean, sorry, 2 and 0.5 neutron will be released. Don't ask like that, foolish. Okay, that is a foolish question. So 2.5 neutrons will be released on an average. Okay, this is one objective question. And number two, uranium is always splitted like barium and krypton. If you see the textbook, in any book, they will give this reaction. By seeing this reaction, the student judge like uranium is always splitted into barium and krypton. That is absolutely wrong. Okay. So the given reaction is most probable reaction. In that case, here 3 neutrons are released, 1 neutron bombarded. Okay. Here, what is the name of this neutron? What is the name of these 3 neutrons? Okay. In this case, whom we used to bombard? Okay. That neutron, the neutron used for the fission, that is to bombard the uranium 230, bombard uranium 235. Okay. So this is the neutron. What is its name? Its name is that neutron used for the fission. Okay. To bombard is called thermal neutron. Its name. Okay. And number three. Here, the 3 neutrons released. Okay. In the reaction, the released neutrons, okay, the released neutrons, better I write like this, the neutrons are released immediately are called, means these neutrons are called prompt neutrons. Okay. And number 4, you have to remember here, barium 141 is not a stable nucleus, Nana. Okay. Krypton 92 is also not the stable nucleus. Again, these two are radioactive nuclei. So the daughter nuclei here are radioactive nuclei. Means if you take this reaction, the fragments left over there are also radioactive. You are using a radioactive element for the fission process, and the fragments which are left over there, not used further for the fission. They are not used, Nana, just they are fragments. Okay, the fragments left in the final bomb are also radioactive, and most dangerous is these barium or krypton or other elements here in the all possible reactions, all are radioactive, and they have more half-life time. This is the problem. Means they won't disintegrate quickly. They take a lot of years together, like 1,000 years, 2,000 years. Their half-life time is like 1,000 or 2,000 years now. Means years together, if you leave them on the surface of Earth, Earth digests those radioactive nuclei once after releasing that bomb at a particular place. The fragments we generally left over there only. Those fragments digested by the earth means enter into the earth, and that region, complete region where the fragments are digested, okay, continuously emit the radioactive rays, okay, years together. And suppose the people enter into that zone, danger zone, they are affected by these emitted radioactive rays like alpha, beta, gamma rays. Here problem is with beta and gamma rays. They penetrate even through bones, and they lead to the alpha rays penetrate through flesh, and they lead to cancer. That's why here the danger thing is the instantaneous phenomenon here when the uranium-235 is splitted, means used for fission process like a bomb. At that time, you may find more amount of energy. By that, lot of temperature will be increased, pressure will be changed. So, lot of demolition we can find at that instant, instantaneously. That is instantaneous phenomenon. But later onwards, what we are seeing here, even though suppose uranium, Hiroshima and Nagasaki only, if you see there, okay, after demolishing that uranium and Nagasaki, again they constructed the buildings and the people are living there. But problem is all those people are affected by this barium, these barium and krypton. Still, the born baby is also coming out with cancer, Nana. Okay, newborn baby. This is the problem. So this is instantaneous. This is a continuous. Years together, those people will be affected. Okay. This is the story here. What he is asking, the data nuclei are radioactive. The problem is they have more half-life time. This is the dangerous one. And one more thing here. The fifth point, what you have to remember, since they are radioactive, every radioactive element tries to attain the stability. During that process, what they do, they release alpha, beta, gamma rays. Along with, they start releasing the neutrons also. So the neutrons released by the daughter nuclei are called delayed neutrons. Okay, this is the problem, Nana. So in the uranium-235 particularly, if you see, there are we are finding out three different types of neutrons. Okay, thermal neutron used to bombard. Okay, immediately after splitting that uranium into the daughter nuclei, immediately the released neutrons are called as prompt neutrons. And these radioactive elements also releasing the neutrons, those are all called the delayed neutrons. Okay. So after the reaction, we are finding out two types of neutrons, prompt and delayed. Then you can ask one question here. Sir, you told the average is 2.5. Whose average is this, sir? This is, keep in mind, average of both prompt neutrons and delayed neutrons. All together, the average we are finding out 2.5. Okay. Now in this whole theory, do you have any doubts? Yes.
Sir, one small thing, sir. This uranium is 235 weight, sir.
No, uranium
Atomic
230.
weight. Means in that state it is stable, sir. Means it is radioactive only, no, sir. In 235 state also.
Yeah, it is radioactive only.
Then, sir, why we need that neutron to split, sir? Means it will split
That is
anyways, no, sir, because it's an.
It is not splitting as Nana. It is releasing small particles like beta alpha.
Yes, sir.
It is not
Okay, means for
splitting,
full
no.
splitting you need. For
Yeah,
that
yeah,
full
yeah.
splitting you need that neutron. Okay, sir.
Yes,
Oh,
yes,
understood.
yes. Now you understood the critical size and everything here, what I explained?
Sir,
Yes, sir.
What is the energy of prompt neutrons? What is the energy of thermal neutrons? Everything. What is the chain reaction here? Any
Yes, sir.
doubts, Nana?
Understood.
Right. Yes, Manduva,
sir,
what's your doubt?
సార్ ఇంతకు ముందే చెప్పిన అంటే రేడియో యాక్టివిటీ కాన్సెప్ట్ లో సర్వైవల్ అంటే ప్రాబబిలిటీ ఆఫ్ సర్వైవల్ అని ఉంది సార్, ఒక క్వశ్చన్ వచ్చింది.
అదే ప్రాబిలిటీ ఆఫ్ సర్వైవల్ అంటే అది ఏం రియాక్షన్స్ తీసుకొని తను సర్వైవ్ అవటానికి ప్రాబిలిటీ ఆఫ్ సర్వైవల్ అని ఉంటుంది అన్నది. తను సర్వైవ్ అవటానికి ఏమేమి రిలీజ్ చేసుకుంటుంది అనేది అక్కడ క్వశ్చన్ అవుతుంది. ఐఎమ్ గెటింగ్ మై వాయిస్ ఓన్లీ.
సార్ ఒకసారి మళ్ళీ చెప్తారా?
సార్ ఇప్పటికే 11:40 అయిందిలే, నెక్స్ట్ క్లాస్లో చెప్తాను. ఓకేనా? రైట్. బాయ్ నాన్న.
బాయ్ సార్.
Bye, sir.